Variation. This is our topic for today. Now, when you hear variation, what comes to your mind? Change, right? Yes. Because in everyday life, you come across the word like it varies, it depends. So if I should ask you, what time would you be around tomorrow? You simply tell me, it depends, right? Okay. It depends on the traffic, it depends on whether I have transport or not, or something might just come up and I may not be able to meet up. So all those of things, they are variation, they are changes, okay? So slight changes in quantities. So that's what variation speaks about, changes. Now, how does this change happen? So how does it affect us? So does it affect us directly or indirectly? So this is what we shall discuss. Variation is a very interesting topic in mathematics, very simple, and you don't have to fail any question from variation. So it's your sure bet in JAMB. Before I embark on my procedures, let me quickly go through something. In mathematics, we mainly deal with two quantities: variable quantity or a constant. So these are the two quantities we treat in mathematics. Now, as the name implies, a variable quantity is a quantity that changes. So it's easily altered. It undergoes changes. While constant or a constant is a quantity that doesn't change irrespective of the situation. So it's just there. It's constant. It remains the same. Doesn't change. Now, what are the examples of variables? And what are examples of constants? Now, let's start with constant. An example of constant is days of the week. Now, how many days we have in a week? We have 7 days in a week. So it's constant. It doesn't change. Okay? It's constant. And another constant is pi, which we use in mathematics, 22/7. It's a constant. It doesn't change. And another constant you come across, there are your letters like 2. It's a constant. 3 is a constant. 2/3. 4. These are constants, okay? They don't change. The values remain the same. 2 is 2. 3 is 3, irrespective of the situation. Hope you are getting me. Good. Now, variable. Variable, the more you work, the more you get paid, right? So the more your effort, the more your results. Yes, because the lazier you are, the more your poverty. No wonder there's a saying, no food for lazy man. So it varies. And also, if I should decide to take transport from Benin to Lagos, the time I will get to Lagos varies. It's not constant. Yeah. If I should ask you, from Benin to Lagos, how many hours does it take? Or from Lagos to Abuja? Or from Abuja to Port Harcourt? How many hours? So you have to take so many things into consideration, like traffic. Like, okay, it depends on the traffic and it depends on the speed of the car. Those are variables. And also temperature. Temperature is a variable because the more you move from one point to another, the temperature changes. Like even the temperature now is different from the temperature later. And also, if it rains or when it rains, the temperature is lower than when it's sun is shining. So those are variables. Once again, variables are quantities that change, so with certain condition, while constant remain the same, they don't change. So I told you an example of constants: letter, pi, days in a week. So anything you can imagine that doesn't change is constant. It remains the same. Why variables can take any value, okay? Example, temperature changes, time changes. And if I should give you something like this, 3s plus 4, okay? From here, it's very easy to point out that the constant is 4, okay? And constant is 3. But s is a variable, so it can have different values. I may be able to say, okay, now, if y is equals 3s plus 4, what is y? So the value of y depends on the value s takes. If I should say, all right, take s as 2. If this is 2, y becomes 3 times 2, 6 plus 4, okay, which is 11. Okay, I think 6 plus 4 is 10. Good. Now, if I say, okay, take s as 3. If this is 3, y becomes 3 times 3, 9. 9 plus 4. You getting? So, those are variables. They change. They are not constant. Okay? And even your mood is not constant. If I should transfer 30 billion to your account, you'll be so happy watching this video. Like, it will be very easy for you to understand. Like, oh, yes, right on, right on, right on. So, your mood is not constant. So, it depends on so many things. Or your mom says, oh, go and wash the dishes. You get upset. So, it's variable. It's not constant. Okay? Good. Even your battery, the rate at which your battery drains depends on how you use your phone. Okay, when you keep the phone, at least the battery lasts longer. But the more you use, watch videos, browse and download films, play games, so the battery runs down faster, gets drained easily. So that's what variable and constant are about. Okay, so variation speaks about variable, how stuff change. But in JAMB syllabus, what are you expected to know under variation? So you're expected to know 4 types of variation or 4 kinds of variation or 4 ways that quantities vary. So the first one is direct variation. Okay? And 2, inverse or indirect variation. So you're expected to know join So these are the 4 types of variation you are expected to know according to JAMB. Direct variation, inverse or indirect variation, joint variation, and partial variation. Now, a question comes to mind. What is direct variation? What is inverse variation or indirect variation? What is joint variation? And what is partial variation? Now, let's find out. Direct variation is a type of variation in which a change in one quantity affects the other directly. Okay? For example, your mom works in an office and she is paid 100,000 naira. So your school fees will be a problem. So let's say, for example, your school fees is 5,000 naira or JAMB registration fee is 7,000 naira. So all you need to do, mom, Please, I need 5,000 naira to register JAMB. She will gladly give you because she has. But what a situation where she loses her job. You understand? So it will affect you directly because getting your registration fee or school fee will be somehow. So, for example, your dad be a billionaire or the president of Nigeria. So I'm sure you may not be preparing for JAMB now. Yeah, I'm serious. So most of the persons in office, their children don't school in Nigeria, they school abroad. So it affects you directly. So that's what direct variation speaks about. So now, look at the formula for variation or proportionality. This is the symbol. So that symbol is proportionality sign or variation sign. Okay. So you can also refer to variation as proportionality. A varies directly as B, or A is directly proportional to B. So they can be used interchangeably. Proportionality sign. So if I should say that A varies directly as B, this A varies directly as B. So this is the mathematical interpretation. A varies directly as B, straight line. So what this implies is that as A increases, B also increases, okay? As A decreases, B also decreases. So they work hand in hand. But in mathematics, we don't solve using proportionality sign. So we need to change this to equal to or equality sign. Because for you to solve successfully, you are supposed to use the equality sign, not proportionality sign. Okay? Because it's difficult to solve this way. Nothing is equating. Then another question comes to mind. How do we introduce the equality sign? How do we change this variation or proportionality sign to equal to? Good question. To change a proportionality sign to equal to, it becomes, you introduce a constant. Because, okay, this is how you change proportionality sign to equality sign. Do you know why? When I say something is proportional to the other or A varies at the other, it means this one of the quantity must be multiplied by a constant value to get the first quantity. For example, A varies directly as B. So it means B has to be multiplied by constant to give me the value of A. So this is sign. You understand? Because they are not equal. So they are not equality sign. You don't need equality sign. You get the gist. So once I multiply B by a constant, it now becomes equals A. So that's what variation is. You get the gist. So understand now that this is the symbol for proportionality sign or variation sign. It's the proportionality symbol or variation symbol. Then to change the proportionality sign or to change this variation symbol to equality sign, you have to introduce a constant. So look at it. A here, B is here. So this is this. So take note of it. Very important. And look at it here. So this is it. This A varies directly as B. Okay? But the way questions come, you say A varies directly as B. When A equals 3, B equals 6. Find A when B equals 1. So this is the way questions come under direct variation. And it's very simple. So we are told that A varies directly as B. So the first thing you do, say, okay, A varies directly as B. All right. So let me change the proportionality sign to equality sign. Okay, fine. I'll say, okay, A is equals KB. Then the first statement they gave us A and B. So they are now saying we should find A when B equals 1. So from the first statement, we have this. That's to say, we have A, we have B, but we don't know K. So what you do, you find K, which is the constant. Okay, good. So to find K, make K subject formula or subject of the formula. And to do that is easy. So this A, this B, and I want K to be equal to every other thing. So that is to bring K out so that K will be equals other stuff. You understand? So K should be equals every other thing to take the place of A. So what I will do is to ensure that this K comes out or stays alone. So I do everything possible to remove B from it. And how do I do that? Let's try something. Let's say this is B, this division sign, right? Let's divide by B and divide by B. Because in maths, what happens to the right must happen to the left so that they will be balanced. Okay? Now, if you have something like this, B divided by B is 1. So if you cancel this, B here, 1. Because it's very simple. If B is 2, that means 2 over 2 is 1. So this divided by this is 1. So this goes remaining K. So we now have A over B is equals K, which can be rearranged. So we can turn this in any way. So K is A over B. So that is it. The next thing is to substitute. We are told that when A is 3, B is 6. So A is 3, B is 6. So we divide. 3 divided by 6 is 1 over 2. So it's half. So that's all. You've gotten the value of constant. But they now say, look at the second statement. Find A when B equals 1. So when A is 3, B is 6, K is 1 over 2. So we are now looking for A when B equals 2. So what to do is very simple. Let's bring back our equality sign, which is here, this equation, or this here. So when you bring this out, or this once again, or the main equation, anyone will do, or better still, here or here, any of the equation. Or I will assume you just go back to the first equation, which is A, the first statement, the first expression, which is A is proportional to B, and like I told you, is A equals KB. So we are now looking for A when B equals 1. So in this case, we don't know A. Yeah. Because in the first statement, they give us A and B. But in the second statement, they say now B has changed to 1. So if B should change to 1, what will A be? Certainly A can't remain the same. Because when B was 6, A equals 3. So it's variation. So when you change one, the other one must be affected. So A can no longer be 3. So let's look for the new value of A. Good. So we don't know A, but we know K. So that's how we solve for the constant. Constant doesn't change. So K is 1 over 2. So it doesn't change. So even when you are using new equation or any expression, so long as this equation is concerned, the constant remains the same. It doesn't change. So it's 1 over 2. Okay? So nothing our constant. So which is 1 over 2 times B. But we are told that B equals 1. So equals 1 over 2. So when B equals 1, A equals 1 over 2. So let's say when B is equals 2, A will be half, which is K times 2 1 times 2 is 2. 2 divided by 2 is 1. A will be 1. So that is variation for you. Precisely direct variation. Okay? Good. Now, indirect variation. Or inverse. Inverse variation. So what is inverse variation? Inverse variation is a type of variation in which the change in one affects the other one indirectly. That's to say, as one quantity increases, the other one decreases. So they don't play. They are cat and rat. So when one is happy, the other one is sad. When one goes up, the other one goes down. So that's to say, for inverse variation or indirect variation, as one quantity increases, the other one decreases. As the other one decreases, the first one increases. So they don't vary directly. So the change in one will bring the other one up or down. So, and what is an example of inverse variation? Now look at it. Let's say I'm running from here to this end. Okay? The faster I run, the lesser the time I need to get there. But the slower I move, the more the time. Let's say for instance, I'm going to that end. Okay. So as speed as speed reduce, time to get there will be more or increase. And you understand? So the faster I move, the lesser time I need to get there. So it's not affecting me directly, it's affecting inversely. You get the gist? So as one increase, the other one reduce. So that is inverse variation for you. Now, how do we solve for inverse variation, and how do we bring out the expression, or how do we interpret inverse variation mathematically? And how do I know that a statement is telling me to solve variation by inverse method? You understand? It's simple. When I say A varies inversely as B, or A varies indirectly as B, or A is inversely proportional to B, you get the gist? So in this case, it's no longer direct, it's inverse. So how do we do that? Inverse means inverting. So 1 over something has inverted. So the inverse of A is 1 over A. Hope you know. The inverse of B is 1 over B. So you are inverting. So, like, let me recall indirect variation. I said this is A varies directly as B, right? Direct variation. Don't you think inverse variation will be A 1 over B? Because it's not inverse, it has flipped. So if this is how you are thinking, trust me, you are correct. But if you are not thinking the same, you have time to join us. Okay? So this is it. You are home and dry. So A varies inversely as B. And this thing, it doesn't have to be do with A or B or S or Y. No. I can say time varies inversely as distance, like I should make the statement. So in this case, time, I can say let time T varies inversely as 1 over distance D. So to make life easy for yourself, you can say time is T, so I can just take T, 1 over distance is D. So you are home and dry. So are we game? Good. So this is it for you. Now, proportionality sign, so we can't use it to solve. You already know. Good. So what we need is A will equals K, right? Then 1 over B. So that is it for you. So K times 1 is K. So it's the same thing as saying A equals K over B. That is it. And while solving, your next step, like we did in the first one, is to make K a subject formula. For example, given the question, A varies inversely as B. When A equals 4, B equals 2. Okay? Then that's the first statement. And they'll ask you, find A. A is now the question. Find A when B equals 3. So it still follows the same pattern. Once you know one, you should be able to solve as many as possible. So see, what we do now, make K subject formula. How do I do that? Good. You know, this A is the same thing as A over 1. So the first one we divided, but here, even if when we divide, we may not get the same thing. Let's try something. Because you may be thinking, in the first one we divided, then why not divide there to get K? So if you don't get it, you can go back to by explanation on direct variation to understand how we divided. Okay, but I don't think we can divide here. Do you think so? Okay, let's see. Okay, let's say we divide by A, for instance. So it will be A over A, right, equals K over A, or K over B over A. It won't work. You get the gist. If we divide by A, it won't work. But okay, let's divide by B and see. A over B is equals K over B divided by B. A divided by B. So this is the same thing as A over B equals K. To turn division to multiplication, you invert. Once you invert division, it becomes multiplication. I'm giving you a remember now, take note of them. So times 1 over B. So it will still work. So what you do in this case is to cross multiply this over 1. So multiply this by this and multiply this by this. So you'll be able to get K. So in my lecture on change of subject formula, you see everything here. So if you've gone through that lecture, you should be able to understand everything here perfectly. Okay? So I'm just trying to do change of subject formula for those who didn't follow that, or in case you did not follow that. So you have something like this. This times this is A, B. A times B is AB. But AB. But A plus B is not AB. It's not AB. A plus B is A plus B. It's like that. So you can't add them. Okay? But you can add A plus A to give you 2A. You can add B plus B to give you 2B. Okay? Then B times B is B squared. So take note of all these things. They are important. So they will help you understand this topic and many other topics. So equals K times 1, which is K. So hope there is no question. Good. So we are home and dry. So the next thing is to implement this first part of the question, where we were told that when A equals 4, B equals 2. So K is equals, A is 4, B is 2. So here you see two alphabets together. So they are being bounded by multiplication, is times. So A, B is the same thing as A times B. Hope you understand. Do you understand? Understand, do you? Good. So which is, it should be 8. So we found constant. And when you get constant, the value remains the same even while you are solving for the other part. So this is the beauty of derivation. So you don't need to look for any other constant again. It's there. Alright. Now, so we've already gotten K. So find A when B is 3. So I'll just go back here. We already know that A is inversely proportional to B. We also know that it means A equals K over B. Then we also know, or we also got K to be 8 and B to be 3. So that's the answer. It's nice, right? So joint variation is a type of variation in which we are that involves two variables or more than two variables. So they are joined directly. So when you have variation involving more than two variables joined together directly, it's called joint variation. So when you see something like A varies jointly as B and C, this joint variation. So it's no longer two variables, we are not dealing with three variables. Okay? And like you already know, and you are a scholar now, anytime you see something like this, you just say A is equals K B C. So you are happy. So another thing you should take note of in this part is how to do change of subject formula in joint variation. To do this, first we are looking for constant. So we'll do everything to make it stand alone. So let's divide by BC, divided by BC. What happens to this side should happen to the other side. And I told you, anything that divides itself will give you 1 except 0. Assignment, 0 divided by 0. So this divided by this will give you 1. This divided by this will give you 1. So 1 times 1 is 1. So it's remain K. But this one you cannot divide because they are not the same. You get the gist. So now K equals A over BC. So we made K subject formula. Because the first part of the question, we always, almost time, require us to find the value of K. Okay? That is it. Now, partial variation is when the variation involves an equation. And how to know partial variation is simple. We see that A is partly constant. How to know partial variation is very simple. You'll be told that A is partly constant and partly varies directly as B. Something like this. A is partly constant, varies as B. So it results to an equation. So when variation that involves addition of variables and equation generally, they are partial variation. Okay, so that's the end of the part 1 of variation. So in part 2, we'll do a lot of calculations in variation for you to understand. So watch out for part 2, calculations in variations or calculations under variation for better understanding. Thank you.